friends, welcome to video lecture on dynamics of machinery. In the today's lecture, we'll learn about performance characteristics of governors, effort and power of governor. Now, we'll cover one by one point under this performance characteristics of governor as first one, sensitiveness of governors, stability of governors, isochronous governors, hunting, effort and power of governor. Let's start with the sensitiveness of governor. Let us consider the two governors A and B running at the same speed. So when this speed increases or decreases by a certain amount, the lift of the sleeve of governor A is greater than the lift of the sleeve of governor B. It is said that the governor A is more sensitive than the governor B. If you just observe the diagram shown below, here when both the governors running at same speed, when this speed is increases by certain amount or decreases, then the lift of the governor A comes more than the lift of the governor B. Then the governor A is said to be more sensitive than the governor B. The sensitiveness is defined as the ratio of difference between the maximum and minimum equilibrium speeds to the mean equilibrium speed. So let us consider N1 is nothing but the minimum equilibrium speed, N2 maximum equilibrium speed, and this N is nothing but the mean equilibrium speed. So mean equilibrium speed is nothing but N1 plus N2 by 2. So sensitiveness of the governor is nothing but, as per discussed during this definition, is the ratio of difference between the maximum and minimum equilibrium speed to the mean speed. So substitute the value of mean speed here. Okay, so we can get that sensitiveness of the governor in this way: 2 n2 minus n1 divided by n1 plus n2. So in terms of angular speed, we get sensitiveness of the governor in this way: 2 into omega 2 minus omega 1 divided by omega 1 plus omega 2. Then stability of governors. A governor is said to be stable when for every speed within the working range there is a definite configuration. That is, there is only one radius of rotation of the governor balls at which the governor is in equilibrium. For a stable governor, if the equilibrium speed increases, the radius of the governor balls must also increase. A governor is said to be unstable if the radius of rotation decreases as the speed is increases. Can be studied with the help of this animation shown in front of you. Here, for the stable governor, when the speed is increases, the radius of the rotation also increases. So in case of unstable governor, when the speed is increases, the radius of the rotation is decreased. So next point for our discussion is isochronous governors. A governor is said to be isochronous when the equilibrium speed is constant. That is, the range of the speed is 0 for all the radii of rotation of the balls in the working range, neglecting friction. The isochronism is the stage of infinite sensitivity. So let us consider the case of Porter governor running at speeds n1 and n2 rpm. So we have this relation with us in case of Porter governor. Okay, so equation we have considered corresponding to minimum radius of rotation. This equation with us corresponding to maximum radius of rotation. So here the Q is considered in the equation corresponding to when the values of alpha and beta are different one, then can get the value of this Q depends upon that. We can just simplify the relation between this height of the governor and speed of the governor. So in this case, when the speed of the governor is increases, what will happen here? The radius of the rotation is changes. So radius of the rotation changes means here the height will changes. Okay. So from minimum radius of the rotation, the maximum radius of the rotation, the variation in the radius of rotation takes place. At the same time, the variation in the height will take place. So if we see here the case for the isochronism, the range of the speed should be 0. That is n2 minus n1 must be equals to 0, or n2 must be equals to n1. So from equation number 1 and 2, if you just equate equation number 1 and equation number 2, so what will happen if I say this n1 equals to n2? So if you equate this one, we can get here h1 must be equals to h2, but this is not a case related with the Porter governor. h1 not becomes equals to h2 because of the radius is changes, at the same time the height is also changes. So hence a Porter governor cannot be isochronous. Now consider the case of Hartnell governor. So in case of Hartnell governor, running at the speed n1 and n2 rpm, we have these relations with us. So already we have discussed about this Hartnell governor in the derivation part. So what's about this one? This indicate the frame, bell crank levers, okay, fly balls, etc. Now, so what's about this one? This equation we are written here by considering the moment of all the forces about this fulcrum point or the pivot point. Okay, so corresponding to minimum radius of rotation, we can get this relation mg plus s1 equals to 2 into fc1 multiplied by x divided by y. The meaning for this one, all the notations we are discussed during the derivation part. So mg is nothing but the force acting on this sleeve, and s1 is nothing but the spring force. Okay, so what's about this fc1? fc1 is nothing but centrifugal force. Okay, the value for this one with us m omega square r. Okay, so replace this omega by this term 2 pi n1 divided by 60. Okay, so we can get next relation. So similarly, corresponding to maximum radius of rotation, get this relation. Okay, so replace this omega 2 term by this 2 pi into n2 divided by 60. Okay, now for the isochronism, n2 must be equals to n1. So therefore from equation number 3 and equation number 4, divide equation number 3 by equation number 4, you can get in this way mg plus s1 divided by mg plus s2 equals to look towards this one, 2 to get cancel, m get cancel, all these terms get cancelled because here n1 we consider for the isochronism n1 equals to n2 or n2 equals to n1. Okay, so only r1 and r2 part will remains here. Next one is nothing but the hunting. Hunting occurs because of the too sensitive governor. Now just here, a governor is said to be hunt if the speed of the engine fluctuates continuously above and below of the mean speed. So like this one, the fluctuations in the engine speed occurs above and below the mean speed. Okay, already I discussed that this is caused by a too sensitive governor which changes the fuel supply by a large amount when a small change in the speed of rotation takes place. Such governor may admit either maximum or minimum amount of fuel. The effect of this will be cause wide fluctuations in the engine speed, or in other words, the engine will hunt. Then effort of the governor. So is the mean force exerted at the sleeve for given percentage change of speed. It may be noted that when the governor is running steadily, there is no force at the sleeve, but when the speed changes, there is a resistance at the sleeve which opposes its motion. It is assumed that this resistance, which is equal to effort, varies uniformly from a maximum value to 0 while the governor moves into its new position of equilibrium. So power of governor is the work done at the sleeve for 1% change of speed is the product of the mean value of the effort and the distance through which the sleeve moves. Mathematically, power is nothing but the mean effort multiplied by lift. So mathematically, power is nothing but mean effort multiplied by lift of sleeve. So as per our discussion, so when increase in the speed takes place, the force of resistance will occurs in opposite direction. Okay, when the sleeve tries to move in upward direction, the resistance force comes in opposite direction. Okay, now say the effort and power of a governor may be determined as below. So let's consider capital N equals to equilibrium speed corresponding to the configuration as shown in figure A. So C indicate percentage change in speed. So increase in the speed is nothing but product of equilibrium speed and percentage increase in the speed. And increased speed is nothing but addition of this plus this, means increasing the speed plus equilibrium speed. So you can get increased in the speed n plus 2n, or n into bracket 1 plus c. Now this is the case corresponding to equilibrium or position at the equilibrium speed, and here we can get the position at increased speed. Okay, now we have discussed that when the speed is n rpm, the slew load is m multiplied by g. Assuming that the angles alpha and beta are equal, so that q equals to 1, then the height of the governor can get in this way: h equals to small m plus capital M divided by small m into 895 divided by n square. Equation number 1 for this. Now when the increase of the speed takes place, a downward force P or will have to be exerted on the sleeve in order to prevent the sleeve from rising. If the speed increases to 1 plus c into n rpm, then the height of the governor remains the same. The load on the sleeve increases to m1g. Therefore, only change will occur here. In the previous equation we get here, only you have to replace this n term by this term. Okay, then the equation we get like this one: h equals to m plus m1. So when the speed is increases, you have to consider this capital M, or load on the sleeve is nothing but m1, and the speed will increase like this one: 1 plus c whole bracket square into n square. Okay, now equating equation number this one 1 and equation number 2, so what do we get here? M plus capital M equals to m plus this m1 divided by 1 plus e whole bracket term will remains. Okay, other terms are same to get cancelled, or here we can get this relation in terms of m1 like this one: m1 equals to this term goes towards the left side. Okay, after simplification we get this m1 equals to m plus capital M into 1 plus c square minus m. So adjust minus m towards both the side, then what we get here: m1 minus m equals to m plus capital M into 1 plus c whole bracket square minus m, this minus capital M. Okay, so after doing this adjustment, so what we get here again, from this minus m, just take this one minus sign common. So what the remains inside of the bracket? M plus capital M. So take m plus capital M common from this and this term. Okay, so whatever the part remains, just that into bracket. So 1 plus c whole bracket square minus 1 will remain. Equation number next for this one. Our ultimate target is to get the value of p as well as x. Okay, so that we can get the this one power. Okay, so already we have discussed about that. Okay, so once we get the value of this one p, so for that, just see here minus m1 minus m into g is the downward force which must be applied in order to prevent the sleeve from rising as the speed increases. It is the same force which act on the governor sleeve immediately after increase of speed has taken place and before the sleeve begins to move. When the sleeve takes place, the new position as shown in figure B like this one, this force gradually diminishes to 0. So let us consider the P is the mean force exerted on the sleeve during the increase the speed or the effort of the governor. So here when we consider the configuration when the speed is increased. So in this case, capital M1 minus capital M divided by 2 multiplied by this G term comes into picture. Already this difference with us. So from this step we get this value. Okay, just replace this term by this term. Okay, so small m plus capital M into 1 plus c whole bracket square minus 1. Okay, will remains inside of the bracket, multiply by g divided by 2. Now expand this term 1 plus c whole bracket square means here what will come 1 plus c square plus 2c. Okay, the expansion of this one. So after this, if you look towards this equation, the value of the c is very small, and to take the square of the same, that term is also comes very small, so neglect the value of this one c square, and remaining part just write it here. Okay, so c square is neglected here, plus 1 and minus 1 get cancelled, So M plus capital M, here the 1 2 get cancelled, 2 2 get cancelled, okay, only C will remain here. C into small m plus capital M into G will remain. Now give the equation number next for this. Now if a frictional force at the sleeve is considered, then the P is equals to C into small mg plus capital Mg plus minus F. So depends upon the motion or the sleeve, movement of the sleeve either in upward or downward direction. We can consider the frictional force as positive or negative. So already I discussed that the governor effort is nothing but is the product of governor effort and the sleeve displacement, okay, or lift of the sleeve. So here we can already we get the value for the force P by neglecting the friction as well as by considering the friction. So get the value of x here. If the height of the governor at the speed n is h and at increased speed, the height in terms of the increased speed with us as h1, then the lift of the sleeve is nothing but 2 into h minus h1 will comes into picture. So we know this one, as there is no resultant force at the sleeve in the two equilibrium speeds there, therefore the two relations in front of you, this one we can get this relation for the height h corresponding to this speed, and this relation, this one for the height h1 corresponding to increased speed. Okay, you can get like this one. So divide this one h1 by h. So to divide this term by this term, so common terms get cancelled and the remaining part, okay, will get like this one. So 1 divided by 1 plus c whole bracket will whole bracket square will remains here, or h1 we can get like this one. H1 is nothing but h divided by 1 plus c whole bracket square. So here already the relation with us, x equals to 2 into h minus h1. So replace this h1 term by this term, 2 into h minus h divided by 1 plus c whole bracket square. Now to the further simplification, okay, so 2 into h, so take this h as common, 1 minus 1 divided by 1 plus c square, 1 plus c whole bracket square will comes here. Now expand this term and make the base common for both this term. Now here we can say again the value of c is very small and the value for the c square is also comes very small, so neglect the c square terms, remaining terms just write in the bracket. So 2h c square we have neglected, c square here we have neglected, okay, 1 here, 1 plus 1 and minus 1 get cancelled, okay. So here 1 plus 2c, and on the numerator part the 2c will remains, okay. Now substituting the value of p and x in equation number 1 5. So what do we get here? Governor power is nothing but p into this term, p into m plus capital M into G multiply by, so this term is about p term, okay. So what's about the x term? So this is the x term, 2h into 2c divided by 1 plus 2c, okay. Now simplify this term once again here, 4, 2 multiplied by 2 means here 4, c multiplied by c get here c square divided by 1 plus 2c will remains as it is. This term this one, this term will remains as it is here. Okay, so H will remains as it is. So governor power, final relation for this governor power is nothing but 4c square divided by 1 plus 2c into m plus capital M into H. Get equation number next for this. If alpha is not equals to beta, that is tan of beta divided by tan of alpha equals to q. Equation number 1 and equation number 2 may be written as, equation number 1 and equation number 2 already with us. Equation number 1 is here, okay, and equation number 2 with us here. Okay, so adjust only 1 plus q term, okay, by considering the gravitational force or weight of this one, we can get this one. Okay, this relation like this: H equals to m plus capital M by 2 into 1 plus q divided by small m into 895 divided by n square. And when the speed increases to 1 plus c into n and the height of the governor remains same, then H equals to, so corresponding to increased speed, you can get the height like this one: H equals to m plus capital M1 by 2 into 1 plus q divided by m multiplied by 895 divided by 1 plus c into n square. So equate this equation with this equation. Okay, so equating, in short, the right side of both the relations. So what do we get here? M plus capital M by 2 into 1 plus q. Okay, this one, and this side, this relation with us. So common part get cancelled and other part, okay, is in front of you. M plus capital M1 by 2 into 1 plus q divided by 1 plus c whole bracket square. Okay, now simplify this one. This term here considered towards one side and remaining terms towards the other side. So m1 by 2 into 1 plus q. Okay, you can write here in this way. Just take this term towards the left side, okay, in this way. And then you have to just subtract this term if you take towards the another side. Okay, so the relation you can get like this: m1 by 2 into 1 plus q equals to small m plus capital M by 2 into 1 plus q, okay, multiply by 1 plus c whole bracket square minus m. So m1 by 2 here, m1 by 2 is nothing but this term comes towards the denominator part. Okay, so this term also goes here in denominator part. So here you can get m1 by 2, just adjust this minus m by 2 terms towards the right side as well as towards the left side. Okay, minus sorry, m1 by 2 minus m by 2 equals to this term with us m bracket 1 plus c whole bracket square divided by 1 plus q, plus this term will remain as it is, m by 2 into 1 plus c whole bracket square minus m by 1 plus q minus m by 2. Okay, so the next step, you can get this term like this one. Take this m divided by 1 plus q common from this side and this term, okay, this term and this term, and remaining one try to write here clearly. So from this term and this one, m by 2 is taken common, and from this term and this one, m divided by 1 plus q is taken common. So we can get this one like this. So in the next step, you can get or simplify like this. This term is common, just take this term as common. Okay, so whatever the remaining part, right inside of the bracket, small m divided by 1 plus small q plus here capital M by 2 into this bracket multiply by this bracket 1 plus c whole bracket square minus 1 will remain. So what's about the governor effort? Governor effort nothing but the P equals to m1 minus m by 2 into g. Okay, so this term already with us, this one m1 minus m by 2, this term already with us. Okay, we look towards this relation m1 by 2 minus m by 2. Okay, so this relation here already with us. Just replace this one by this term, this one small m plus small m divided by 1 plus q plus m by 2 okay, this one, this term here, this square term is neglected because of very small term. Okay, plus 1 minus 1 get cancelled, so remains here and g, okay, written here. So what's about the next step? Now the next step can get like this one 2m divided by 1 plus q plus this one m into g. Okay, so here only 2 is multiplied, okay, here and divided to this term. Okay, so we can get simply this equation. So from equation number previous one 6, from this one we can get the value of x like this one 1 plus q into h into 2 divided by 1 plus 2c. Okay, now the governor effort is nothing but is the product of, sorry, governor power is the product of governor effort and displacement. So displacement one, governor power with us, this one, so already written here. And what's about the displacement? Displacement with us here 1 plus q into h into 2c divided by 1 plus 2c. Okay, you can get the governor power. After that just simplify this term, okay, like this one multiply by this one c, here we can get c square. We look towards here that with us, so 2c square divided by 1 plus 2 written here like this one. Then we look towards next terms. Okay, here m, make the base common here. Okay, so 1 plus q and 1 plus q get cancelled. You can get the final relation for governor power, that is 4c square divided by 1 plus 2 to bracket small m plus m by 2 to 1 plus q into g into h. So the same method we can apply for another governors also. Okay, get the effort and power of the governor.